live, Clemens. Ask me question when it's live is. Yeah. Hello, everyone. Welcome back again this week to weekly webinar sessions. We are trying this week a new format where I, Matthew Tam from Karamba, am going to be participating together with Junghwo Park in this webinar. So, I'll help him to mediate and communicate with you in regards to the chat. Once again, this week we are talking with Junghwo Park about the Rhino.Inside with Karamba3D. If you guys have any questions or comments, please feel free to write them in the chat group. And if there's any problems, feel free to also communicate this to us. We'll touch on some topics that some people sent some questions last week in regards to the webinar that Park gave last week. So we'll address this first. So thank you, Park, for joining us once again.
Hello.
There was a question in regards to units and how units work with Revit and Grasshopper and Rhino in general. Would you be able to clarify this for our users a bit more in detail so that they understand a little bit more?
Sure. I'll show prepared one example from the question. I'm going to open one existing Revit file in millimeter that we can show how the unit works again between Revit and Rhino. In this example file, we draw one simple beam, and the initial project unit from Revit is millimeter. The most important thing between Rhino.Inside and Revit in terms of units, that the Rhino's unit is most important part for Karamba3D. So even though Revit's unit is millimeter, initially when we go to add-ins and click on Rhino.Inside, then Rhino will initialize Rhino.Inside unit. Basically, Rhino take over unit from Revit's project unit. Once it's initialized, then we can click on Rhino.Inside on the top right corner. And now I'm going to open Rhino inside of Revit. And as you can see, if we go to unit setting here, bottom left, it shows already millimeters. So Rhino.Inside takes units from Revit. And of course, when we open Grasshopper is taking over Rhino's unit, basically. And now if I open simple beam definition from here, from Karamba3D, then of course for example, we take the structural framing from Revit with Rhino.Inside, and we convert Revit's geometry to Grasshopper elements so that we can measure the length of line. And at the moment it shows 1000 unit, but this means actually Karamba doesn't understand millimeter. It's Karamba always recognize this unit as a meter, so it might be problem when we use millimeter unit from Rhino. What we can do is we could set new unit when we open Rhino.Inside, and we can change unit to meters. When I hit OK, then your Grasshopper definition still recognize 1000 unit from previous memory, but we can hit mouse middle button and there is one icon shows recompute. This recompute is basically recomputing the memory between Grasshopper and Rhino.Inside in Revit. So when I recompute, then the unit is now recognized to meter. Sorry, the 1 unit, which means in our Rhino unit, sometimes when you change millimeter to unit to meter, now the object become too small. Then I can give you another extra tip. You could select any component in Grasshopper, and with mouse middle button here you can zoom that object in Rhino space, or you can also control in your key Control Shift E to extend the object in Rhino. So in terms of unit conversion, the best way is really define the unit before starting the project. But nevertheless, the Revit unit is different to meter. You can always change in Rhino, and Rhino's unit is most important for Karamba. So as long as Rhino unit is meter, then you could recompute the new unit, and your Karamba3D definition will work as usual. So Matthew, that's the unit demonstration. Is there any other specific question from last session?
No, that was basically the only question that we had from last week. Also, another note, Park, if you are able to bring up the Grasshopper window, we can also check in Karamba or Grasshopper itself the total length of the model. If you just bring this up in Grasshopper again.
Yep. Exactly. Here.
In Grasshopper, yeah. So if you zoom in on the panel output for model, in the assemble model component. After the assemble model, so yeah, here you can see the model C length in the panel output there. Yeah, so this tells you the length of the model there.
Okay.
The model C length there.
Yep,
so
I'll just
also do one final check to
Yep.
see if the model is correct.
Okay,
Yeah.
that's good.
Okay, thank you very much for that.
Okay.
And basically, you can continue then with the content for the webinar.
Good. Then I'll continue from last session. I'll go to now part 1 example. Close that. So last week I was showing basically how we could convert Revit's existing model from analytical model to use in Karamba3D. Again, at the moment, before we initialize your Rhino.Inside, it's always good to check which your project unit in Revit. At the moment, I'm using meter for this example, so I'm going to click on add-ins, and to initialize Rhino.Inside, click on Rhino. Then we will have extra ribbon in Revit Rhino's, and I'm going to open Rhino. And you can type here Grasshopper, or you could also click Grasshopper button from here in Revit. Then the Grasshopper window will pop up. Okay, and I will show Rhino as well. So open the definition here. So we create Karamba analytical model in Rhino environment now. by referencing Revit's analytical model. And here I would like to show some important tips, because we have now here cross section, which is columns, two columns. They are connecting from structural foundation slab to floor slab, and sometimes it's difficult to find the exact node points between those two slabs and two columns. One of the tips we could use, when you see from this columns analytical line, we could extract start and end point, and this start and end point we can connect to Karamba meshed wrap component. This allows us to connect or basically welding the vertices on mesh surface to those connecting point. So for example, now if I change my mesh resolution, as you can see, the connecting points between columns analytical lines and those analytical surface, they are always welded. So in this case, we don't have to worry about which resolution to use in Karamba3D. This is very important when we work with different floors and structural framing members in Karamba3D. Another important point I would like to explain, in Karamba, we could also define solid cross sections by using trap raised cross section. So when you click on Karamba3D's cross section component, we can choose different profile for the cross section, and eventually here when I specify it to trapezoidal cross section, then here we can define height and width of the member. Basically here I'm defining the concrete column 30 centimeter by 45 centimeters, and this input unit in Karamba for cross section, they follow centimeter. So you just define centimeters to create solid cross section. And of course, from the material, the initial cross section for trapezoid is steel material, so that's the reason why I have to define here extra concrete material to define proper material for Karamba3D. So these parts, the remaining parts are more or less same as all previous webinar. I just want to demonstrate once more here. Let's say when I'm going to change the graphic to black and white. So if we change now Revit geometry, the original geometry, then Karamba definition should automatically up to date. So for example, now I'm going to manipulate the change the geometry. For instance, the offset I could up to date here, and maybe here update. Then now we have bigger foundation slab and also floor slab, and maybe we can define different column grid. So now our physical model changed. The important thing now, what we have to do in Rhino.Inside, we have to recompute new input from Revit to Rhino. So once I recompute, then your Karamba is automatically update. Karamba3D's definition is automatically inherit the geometry input from Revit, and now we have updated analysis in preview. Of course, with this function, we could always use extra Karamba's tips. For example, we can display deformation in Revit. If I go here in RhinoInside, yeah, and according to Revit's input, Karamba3D works pretty well with RhinoInside. This is the first part. The last, the most important part from the first part. I'm going to now move on to second part. Is there any specific question so far?
I think at the moment we do not have any questions, so you can feel free to continue. I did want to ask you about the deformations, but then you just explained that too, so
Okay.
that's it. Yeah.
Okay, great. So I'm going to one of the a bit tricky part of RhinoInside is that even though I completely close my existing Revit model, you still run RhinoInside within this program. So it's always better to completely close your Revit application, and I would recommend to open again new Revit in order to start with new project file. So this is also one of the things probably McNeil need to improve. But anyway, I'm going to open second example file here.
While we're waiting for this to open, one maybe information that our users will be interested in is that on the RhinoInside Revit wiki page, or the resource page that you showed last week, there's also like a list of sort of like a roadmap of what McNeil is currently developing and what they're planning to release and what the goals are for example, for the year. And it has been sort of announced that they plan to release Rhino7 this year, so we anticipate that this will become a fully fledged sort of professional program in the coming year, RhinoInside Revit.
That's great news as a game changer. Now I'm going to open second example that we prepared from last time. So first part I showed how we can convert Revit's geometry, for example, analytical model or the model lines to calculate in Karamba3D. This time I would like to show how Karamba3D output can be interpolated in Revit, its native geometry. So when we open second examples, basically we could select them all. I could unpin the existing element and I can delete them all. It's no problem. And before we initialize our RhinoInside, I always double check once more my unit. For me, I'm very comfortable with the meter at the moment, so I'm using our project unit as a meter. Now I'm going to click on Add in RhinoInside. Then Revit will initialize RhinoInside inside of Revit. So it's as you can see, our task manager, that Revit is now handling more memory than usual. Okay. So now it's opened. I'm going to click on Rhino icon, and at the same time I'm going to click on the Grasshopper icon here. Now second example is actually I'm taking over the example from previous webinar series with Otto Wagner's bridge example. The Matthew and Clemens already explained all detailed part of Karamba3D in this example, and now how we can actually convert these members or results to Revit in Revit by using RhinoInside. It's very simple. On our examples, the Grasshopper canvas, at the end of the canvas we have RhinoInside components. The reason why I delete all previous elements is that I would like to create new levels and members. If I because they have different memory, so when I actuate my Grasshopper definition again, they create new elements which is duplicated, but the GUID is different GUID. But anyway, they will create initial additional elements. That's why I delete them all. Before we convert to any Revit's native elements, it's always nice to have levels in Revit. So I'm going to enable here in our definition the Revit levels components from RhinoInside. When I enable, then RhinoInside Grasshopper definition will create Revit according to the Grasshopper definition here. So the foundation level about -5 meter, and we have 0 for cross-section grid level, and have 3.2 meter for archtop levels. And after that, we could convert. We can enable all this definition to transfer all the results from Karamba3D to Revit. Now, if I minimize my Grasshopper definition, let's go to 3D view, and here in RhinoInside toggle bar, we could also turn off the preview from Karamba3D. I mean, basically from Grasshopper. So as you can see, we have all the members that created from Karamba now transferred to the Revit's native members. So by using RhinoInside, we can now convert these graphical information to more detailed building information modeling information. So the workflow is here. I'm going to show. Basically, we can take the members' curve lines from the line before using line to beam members. We could take the member input, all these curves in this container, and then of course you don't need to use remove duplicated lines. But here I just in case to see if we have not duplicate lines to convert to Revit. So this component is Kangaroo2 components to use, or we also have Karamba the component called remove duplicate lines or point that does quite similar result. That gives us similar output. And these lines now we can convert to Revit's structural framing. When you go Revit here in RhinoInside Grasshopper components, on the build we have these components which allows us to convert Grasshopper input to Revit's native components, such as beam or columns, and floors, walls, and roof, and etc. And I know that already in my Revit's project file which families are loaded in, for example, those examples. So I could specify from structural framing category, and then family types I can specify by using the family type component. So you can connect, and then from here drop down menu you can choose the loaded Revit family members. And I know that this diagonal Karamba diagonal members is round 20 stills cross sections, so I can convert that output family type to family type input, and the lines I used as a curve input. And important thing here, we could also define the reference level for those members. So here in Rhino.Inside, we have a component called document levels, which load all the existing levels from Revit file, and then those named levels I can take the index from item index, and I know that I want to use this round steel to foundation level, and this container level container is basically taking the levels to in this container, and I can put input in add beam components. Then we know that which line need to be converted to this specific type of structural members and which level it's going to be displayed. So when I go to Revit once more, when I click on the this diagonal member, that as you can see, the reference level is assigned to foundation level. So this is the tips. Of course, we convert directly from Karamba to Revit native components, which means as long as these members are enabled with analytical model, then we can also take a look how Revit's analytical models are built up from Karamba3D. I prepared the view already here. When you double click on analytical model from your project browser, then here, as you can see, between physical geometry from Karamba3D and the analytical model from Karamba3D is enabled in our Revit. And of course, it's very important to know each node points if they are automatically connected. Why it's important? Because we could send this data to third-party calculation software from Revit. For example, RFEM by the Ruber company, or Sophistic, or robot structural analysis software from Autodesk. So then we can do the extra calculation from those softwares, and most of softwares, they support bi-directional link between Revit and third-party softwares. So recalculated members from extra static softwares, we can bring it back to Revit. Then the bi-directional the function will automatically convert the existing members by recognizing the GUID from Revit.
Sorry, there was a question in relation to this about calculating curved bridge beams. So like you've explained how you can convert this into a single curve in Revit. But when we are working with the geometry in Karamba and calculating as a structural analytical model, we have to split every curved element into separate line segments in Karamba before you can calculate it. So Karamba performs slightly differently to how Revit or Sophistic, for example, might perform in terms of its analysis of beam elements.
Right. In response to that question, I can show here, basically, not every software needs to split all the segments, but Karamba3D needs to split those framing members between the nodes point. What you can do to convert one single curved structural framing in Revit, but we could actually use, for instance, this before we converting to Karamba line to beam components. These members probably I'll show in Rhino view. So these are the points we generate generate the polyline, and then we have to explode because this polyline to convert to line to beam component. And basically what you can do, we can take over the node points before line to beam component, and then we can remove, in case of duplicate points, we can remove duplicated points, and we can split the data because we have right now 2 arced beams. I just used Grasshopper simple list operation here, and then we can connect one to each line to interpolated line component, as you can see. And then one of them has to be here. So we have these 2 different curved line, and this line we could join, and then that joined one single curved line. We can use same definition basically here. So that single line I can now convert to the same family type, and we send it to Revit. As you can see now, it's not segmented beams, but they are 2 single members. Let's go to Revit, and if I isolate this beam here, that's the instead of segmented beams, we can use one single beam. Of course, then, as you can see from the analytical modules, I know that Sophistic or some other softwares, robots, they could recognize that curved line to calculate. But we can always choose different options depending on which additional calculate software you use. But just keep in mind that I know it's a little bit more too detailed, but before sending to third-party structural calculation software, you better to approximate curves so that you follow kind of similar Karamba3D segments to get a similar result. Okay, Matthew, I'm responding to the question here. Any other welcome. Any other specific questions so far apart from single beam?
No, that's all for now.
Okay.
So you can continue. Thank you.
Okay. And of course, with the Rhino.Inside, with the second example, if I go now, enable the preview from Grasshopper, shade view, then I'll go Grasshopper to display the result from Karamba3D. And as you can see, we can see the Karamba's preview in Revit view. Of course, it's really nice in here, because we could also display field moment diagram in Revit. So previously we had to always reference from Rhino preview to display this kind of diagram from Karamba3D, but now it's we can do in live with Rhino.Inside inside of Revit.
Sorry, there was one question in regards with different cross sections. What we have done with this is that the cross section for the arch is the same cross section overall. So we have not applied any varying cross sections. But of course, if you have done this in your Grasshopper or Karamba script, this information can also then be fed into your Revit. And I guess has already shown, for example, how to create these beam elements, you have to then have the families already in Revit, for example. So you cannot just simply change the cross-section in Karamba and expect to have the geometry working for you in Revit natively. Is that correct?
Yep. I see some other question. For example, if we can differentiate the sections instead of one single.
Yes, this was just this question that, like I said at the moment, we have only 3 different types of cross sections, I believe, in this one. We have the I-beams for the arch. We have the circular members for the diagonal, for the bracing elements, and then we have some rectangular elements. And so you've created them for each separate set of elements, but if you want to differentiate, of course, use something that you can do in the Karamba script and also in your Revit file.
Exactly. And additional to these questions, you could also use additional Grasshopper plugin. For instance, we have in Karamba, if you look at Karamba's output, Karamba3D's output, we have ability to export Karamba result to Deliver software or robot structural analysis. But there is also plugin called Geometry Gym, which allows us to automatically generate all cross-section members from Karamba3D and then converting into Revit without any manual work. So in this example, I prepared all the cross sections based on Karamba input. I manually create the members in Revit. As you can, I had to load it, but with some plugins, or we could automatically generate the members. Or another option we could use is we could generate type catalog CSV file based on Karamba's definition. This text file allows us to bring all the cross-section members which we used in Karamba automatically. So what it means, you might know when you use Revit, you can load family, and then there we can load, for instance, structural framing and steel member. When we load this member, this table chart is automatically pop up. This is called type catalog file, and of course we can script additionally to generate all these different members from Karamba3D to load all the different types of members in Revit. Then that also make your workflow a bit easier in practical way. All right.
There's one more question I think maybe we can touch on before we finish for today. Someone was asking about to do structure analysis in Revit. Well, basically you saw from the tutorial that basically we are able to generate also the analytical model with the beams that you created, correct? So you can perform a structural analysis in Revit now with the elements that you created using Rhino.Inside. Is this correct?
Yes, right. So it's once it's now in Revit's data environment, then basically it's native Revit elements. So you can do any further operation what you used to do in Revit. So it's just pure Revit natives elements. You can use it for any Revit structure calculation, or you can also use any extra third-party plugins to use it. Yep.
Yes. Were there any last things that you wanted to mention today?
Today I think it's enough, and next time I will go the third part. Sorry, the last example to show. For instance, we may have in Revit that geometry is not every beam is segmented. So how we can deal with Karamba3D to reference these kind of beam from Revit to split in Karamba3D and use that input to calculate structural analysis. So third part is going to be a bit more complicated, than last two parts, but it will be more interesting, I think, in reality scenario.
Yes, that's great. Thank you very much once again for this great webinar session, and we hope you are all able to join us once again next week. Thank you very much, Junghwo,
Welcome.
and hopefully we'll have you back next week to explain this last part of the first in our Revit Karamba3D series. And feel free to write any comments, questions at us at any time in the chat or in the comments of our YouTube videos, and please share also the videos with any of your colleagues or friends. Thank you once again, and hope to see you next week.
Thank you, Matthew. Thank you very much for watching it.
Bye bye.
Bye bye.